And we're going to go ahead and get started with lesson 3.5, which is the equations of parallel and perpendicular lines. The concept that we need to review as we begin this is the concept of slope. So we reviewed this in class, but slope is represented by the mathematical variable m. What it means is that we have the vertical rise over the horizontal run. We're always going to apply our negative to the top, so we rise and fall, and then run to the right. When we do that, it is going to be the change in y over the change in x. This triangle right here is the Greek letter delta, which stands for change. And the way we calculate that is we're going to take a difference between 2 points and both parts of their coordinates. So the difference in the y values of 2 coordinates over the distance, the difference of the 2 x values of 2 coordinates. Now, this doesn't always have to be the first minus the second. It could also be the second minus the first. So we could think of it as the following, is that y sub 2 minus y sub 1. Remember, these are subscripts, right? This does not mean the first power, it's just the first y. And then as long as we do it with the corresponding with a second x to the first x, right? So it's always 1 minus 2, 1 minus 2, right? Or 2 minus 1, 2 minus 1. In that order, we are good to go. So let's do a little practice here. We are going to find the slope of 2 coordinates where we have -1, -5, and we have 1, -4. Now, gentlemen, I'm going to suggest to you the following. Whenever that you guys put something in to an equation, like when we have slope, what I want you to do is that I want you to replace each of these variables in parentheses. Now let's go ahead and label each of these coordinates. We have -1 as this first part of the coordinate, and this is of course in alphabetical order, x comma y. So this is an x and this is a y. And we can label this as our first x and first y. So everything else is dictated from there. This is also an x. That's the first thing listed. But it now has to be the second x because I already have it first x. And this is going to be y sub 2, the second y. So I plug it into my equation. I have -5 minus -4. And I put these things in parentheses. This is going to lead to fewer mistakes. -1 comma minus 1. Which really is going to give me a -5 minus -4. And then a -1 minus 1, which is really going to be a -2. -5 minus 4 is -1, negative over -2, and both those being negatives is going to yield a positive 1/2. Now, for the sake of demonstration, you don't have to do this twice, but just to show you that we could have done this assigning different values for these coordinates. So we have x sub 2. Because this was previously x sub 1, and we'll just call this the second coordinate rather than the first one, and call this coordinate on the right the first coordinate rather than the second one. Let's see what the result is. So we'll have a -4 minus -5, right? And then I'm going to have 1, oops, yep, 1 minus -1, which is going to give me a -4 minus -5, and I have a 1 minus -1. -4 plus 5 is 1, 1 plus 1 is 2, and I get the same exact thing. So it doesn't matter as long as I'm consistent what I choose as my first and what I choose as my second. All right. Next, let's talk about slope in regard to lines. So for parallel lines will have the same slope, okay, versus perpendicular lines have the negative reciprocal as the slope. So what I mean by that, the slope, for example, negative reciprocal. So if I have 3, the negative reciprocal is going to make 3 negative, and I'm going to flip the fraction upside down, right? We talked about this briefly in class, but 3 is really the same thing as 3 over 1, okay? So what if we had -1/2 as my slope? Well, flip it over, 2 over 1, and then make it positive, and 2 over 1 is just really 2. Here's a more simple one. How about -5 over 4? We'll flip it over, switch the sign. So this is going to be a positive 4 over 5. Hope you guys get the idea here. All right. So next problem that you guys are going to get, we're going to determine if two lines are going to be parallel or perpendicular or what the relationship is going to be. All right. So let's graph these things in a coordinate plane. Give me just a moment. Okay. So negative 3, 1 is my first coordinate. And 2, 3, 4, 5, 6. 1, 2, 4. So this is 6, 4. And this is negative 3, 1. So that's one of my coordinates, or one of my lines with two of my coordinates. And then I'm going to take another line here, okay, which we have 0, 1, 2, 3, 4, 5, 6, 7. 0, negative 7. And then we have 8, 7, 8, negative 2. Okay, so what's the relationship between these lines? Are these just two lines that are intersecting? Are these parallel lines? And if they are, then they have the same slope, or are they perpendicular? Now, we can't just go upon a visual and say, oh, they don't look to be parallel or perpendicular. To deductively prove this, it means that we need to calculate slope. Okay, so let's go ahead and do that. I'm going to go and assign values to these. So I'm going to first do this guy on the left and find my slope. So this is my x, and we'll call this guy x sub 1, y sub 1, meaning that this is my second point. So I have x sub 2, y sub 2. And I'm going to plug this into the slope formula. So I have the difference of my y's, 1 minus 4, over the difference of my x's, negative 3, minus 6. Okay. Negative 1 minus 4 is negative 3. Negative 3 minus 6 is negative 9. So this will be a positive 1/3 as my slope. Now I'm going to work with this one on the right side. So this is going to be x sub 1, y sub 1. So this is going to be my second point then. And I could have done in either order. It doesn't really matter, right? In fact, let's do that. Let's switch it up. Because why not? Let's make this guy the second point. Make this guy the first point. So my slope is going to be 8. Oops, it's going to be y over x, right? So negative 2 minus negative 7. And then I'm going to have 8 minus 0. So I have negative 2 minus minus, right? So plus 7 over 8, which is going to give me 5 over 8 as my slope. So I have this and this as my two slopes. So what is my relationship? Well, these lines are not parallel because they have different slopes, and they're not perpendicular because slopes are not the negative reciprocal. Okay? These just are two lines, and of course what the relationship will be is that they're intersecting. All right, next. We are going to write an equation of the line passing through the point negative 4, 6 that is parallel to the line y is equal to 3x minus 4. So let's recall we have this slope-intercept form of a line, which is y equals mx plus b. Ah, yes, it comes back to us. Remember what these various parts mean. You guys know, of course, the coordinates y and x, but m is, of course, what we discussed and is defined as the slope, mathematically what we use when referring to slope. And then b is the y-intercept. In other words, when x is equal to 0, where does the line cross on the y-axis? That's our y-intercept, okay? So let's start to throw some of these values in here. Now, I have my coordinate here, -4, 6. So this is my x comma y, right? Now, what I need to do is figure out my y-intercept here. And what I'm going to do here, since this is going to be parallel, it's going to have the same exact slope. So I'm going to steal this slope, a 3. Okay, so my m here is going to be equal to 3. When I plug all the stuff back in, my y is 6, my m is 3, my x is -4, and then I'm going to solve for b, so to create my new equation, right? So this is going to be 6 is equal to -12 plus b. I'm going to add 12 to both sides. It cancels. 6 plus 12 is going to be 18, and that's my b. All right, and then what I do here is I'm going to take this equation over here, okay, and I have my y. I'm going to take my borrowed slope up here, because it will be parallel, 3x, right? And then I'm going to plug in my b, all right? So that's going to be plus 18, and this is my new equation, and it is parallel to this one, all right? 3x minus 4, because they both have a slope of 3. They just have different y-intercepts. Next, let's write an equation of the line passing through the point -12, 6, that is perpendicular to the line y is equal to, and this is going to be a fun one, 2/3 x minus -10. All right. Let me move this guy down here so this looks better visually for you. There we go. Okay. So, some keys here. Perpendicular. Okay. So again, I need to take the slope, because this is how we're going to base my new equation, but I need to modify my slope. This guy right here, we're going to have a new slope. Remember, how do we make a perpendicular? Well, my slope is 2/3, so perpendicular would be the negative reciprocal, so it means it's the negative flipped over version, -3/2, okay? So I go back to the default of y is equal to mx plus b, okay? This is my x, this is my y, and then I have all the stuff I need to continue on. I have my 6 is my y, my m is this, -3/2. My x we had over here, right, which is going to be 12. And then I'm going to add b. And then I'm going to do a little bit more algebra, right? So this guy is going to factor out. That'll give me a 6 right there, right? I have 6 is equal to -3 times 6. I'm sorry, times. Guys, I got this all wrong. I am missing my negative that's in there. That would have been a disaster. So I have a -3 times in my -6, and that will give me a positive 18 plus b. I would have gotten the entire wrong value. And that's very common, guys. You guys can see that I just made a transposition error there. The transposition errors are common, okay? Don't really know what to do except for tell you just not to make them. And we just make sure that we're writing things down. But they happen. You guys see, even I make them from time to time. Okay, 6 minus 18 is -12, and that's my b. And then I'm going to take that, right? And now I have my value for b. So I have my y is equal mx plus b. I have my m, -3/2, my x, and then my mu b is -12. And that's going to be the equation that will be perpendicular to the other equation passing through -12, 6. Last thing, we're going to find the distance. Oh boy. So we already know it's coming up. You guys are going to see distance, so distance formula is for sure going to be used. From the point 6, -2, and the line y is equal to 2x minus 4. All right. We got a little bit of work on our hands here. So, first things first, we're finding distance. Distance formula is going to be part of it, okay? Next, we need to find the distance from a point. Now remember, the shortest distance is going to be perpendicular. So I'm going to take this point or take the slope and I'm going to modify it to be the negative reciprocal. And that's going to be my new slope for my equation. Here are my x and y. Okay. So I have y, which is equal to mx plus b. So then I have my negative 2 is equal to, right? My negative 1/2 is my m. My x is 6 plus b. So negative 2 is going to be equal to negative 3 plus b. Add 3, add 3. These guys cancel. Negative 2 plus 3 is 1, and that's my b. All right, bring this guy down here. Oops. And in my new equation, y is equal to, I have my stolen and modified slope, negative 1/2, so x plus my 1 right here, okay? This is my new equation. Now, I want you guys to look at something here. I've got two equations. I got this guy and I got this other one. So I'm going to write them side by side. I have y, which is equal to 2x minus 4, and I have y, which is equal to negative 1/2 x plus 1. What am I looking at here? This and this. What are these things? Well, these are lines. These are equations for lines. I can graph these in a coordinate plane, but I'm never going to graph. I want to figure out where these two lines intersect, because I already have a point that I have to find a distance from, which is this guy up here. What I need to find is where these 2 points, or these 2 lines intersect each other. Well, they're going to intersect each other where they're equal. Both of these things equal y, so therefore they're going to equal each other. Actually, I'm going to do this in black. So 2x minus 4 equal negative 1/2 x plus 1. All right, add 4 to both sides. So I have 2x is equal to negative 1/2 x plus 5. Let's get all the x's on one side, so I'm going to add 1/2 x to both sides. Now, here we go. Take a look at this. What's 2x plus 1/2 x? Well, it's 2 and 1/2 x, or as an improper fraction is 5/2 x, which you'll thank me in a moment why I actually put it as an improper fraction, because let's go ahead and solve. Let's get the x by itself. We're going to multiply both sides by 2/5. Watch what happens when I do that. Everything on the left factors out, and I'm left with just my x. And even on the right, these 5s factor out, and I'm left with my 2. So I have the x value. Now, here's what I'm going to do. I'm going to take this x, and I could put it into either one of these equations. It'll give me the same thing, but I'm just going to do it in the one on the left, because I think that's going to be easier to evaluate. 2 times 2 minus 4. So y is equal to 4 minus 4. So my y is equal to 0. So this is a coordinate right here. This is the coordinate 2, 0. This is where the 2 lines intersect. Okay? So now I have a brand new problem where I effectively need to find the distance between my first coordinate, back up here, 6, negative 2, and 2, 0. And we now use, you know it, the distance formula. So d is equal to big square root, right? The difference of my x's, 6 minus 2 squared, plus the difference of my y's, negative 2 minus 0 squared, okay? Negative 6 minus 2 is 4 squared, plus negative 2 minus 0 is negative 2 squared. 4 squared is 16. Negative 2 squared is 4, so this is the square root of 20, which we did earlier in class, which is going to be 2 rad 5. And this is the answer. It's the whole purpose of this problem, all right? Good luck, gentlemen. I'll see you in class. Come see me during my office hours if you have questions.